It's time to look at it. Also, I've taken another course at the university, which is timer clock, which we saw in the code. I think might work is, for example, here, which I'm going to use this FPGA, and then I need an interface card to test this code. So I put the FPGA in here. And this looks like SMD resistors, but they are actually just there for you can't see it, but there's actually a connection there. It's just to get the possibility to break a connection if I want to route something from one point to another point than the one that I already have. Right, now it's programmed. Let's get it in there. So let's turn it on. Oh my god. So I made a little program that I'm running here, which is replacing the kernel. So this is the setup. We have the kernel there, which I programmed in the MiniPro. We have the Digilent, digital discovery connected to the CIA. I have time of day here connected into count. So you can start at E. And I did a lot of back and forth. I realized I had done this wrong. So, but now it's correct. So what I'm doing is that I'm putting something in the latch of timer A, CAA, and I'm starting it. And also this value says that it's going to start counting time of day, which is 50 Hertz. And then I'm just reading it over and over and over the timer A low byte. And actually now you can see this value here is decrementing. This is the time of day value, which is read out here. If I do this, you can see ship select there, address number 4, which is timer A, is decrementing. So that's basically it. So last night I had some problems here, and I could see on the logic analyzer that I get data in and out, but when I try to dump the register access onto here, I could see that it wrote D55, but what I actually is writing is E54. So something's wrong with the address lines. The thing is that I didn't have enough I/O here, so I've used some I/Os from this high rows connector. And I don't think this one has 5V tolerance. I will try to fix that. Okay, I think I've fixed the problem with the RS, or the address. So now you can see E54, and that's exactly what I'm writing in the program. So the FPGA is storing every write here, and I display it. So what it has been written to it is this sequence, 4, 5, and E. And that's what you can say in the start of my program, 4, 5, and E. So that's great. So now I've fixed the RS thing. I had to reroute here, made some cuts, and yeah, reroute RS, as you can see. And then I can show you. Reprogram. This is my way of resetting anyway. Then I will have to restart the computer, and there you go. So now I have to see if that the counter is running. So I have to repurpose this display again so you can see something. So there you can see I read out last RS, or the last registers RS. Actually you can see it in my phone. Yeah, whenever there's a write, I update last RS with a bit shifting, so with the address and everything. So what I'm going to do now is to repurpose. So what I want is the timer. So yeah, so that's what we're gonna do. 15 down to 12. There it goes. Let's try programming that. Right. it did work. So let me show you. So I had to program this thing, and then when I started, it shows 10 OF, and that's actually one value down from 1.0. So sort of it has started, but it has decremented one bit. But it's not counting. Why is that? Well, it's actually counting time of day, but I have to connect it first. So you can see time of day there. So let me show you time of day connected to count. Look, that's so cool. It's counting down. Oh, sorry. So you can see it's now E, and then it will be D. So there you go. So my program is working after all. It just had some connection issues here. Okay, it's next day. So, and we saw it yesterday that we had 10 OF or something. So it had counted one down before I had actually started it. So now I'm going to test with the real chip. So what I'm doing now, I'm not starting the timer, I'm just well, I should actually start the timer, because the only difference was that the count pin wasn't connected. So let's try that. But anyway, let me show you. We had two reads here, 4 and 5, and we can see they are both 10, 10. So I forgot to start it. There you go. Now we have load 21, so it should start. I have assembled it. Now we'll burn it and put it back in there. Okay, I programmed the thing and I'm loading 21, and you can actually see it here, actually, into E. However, here you can see only 10 and 10, so there's no, it's not decrementing, and if I continue to run the thing, it still shows 10 and 10, so, or 10 for those who like that. So something's different between this one and this one, that's for sure. So I have to put it away, I have to sleep, and then I have to work the next day. So I need a computer screen a bit closer and stuff. So actually did fix this thing with starting at 10:10, but I think I'll make a program now that tests every corner case, because then I can test all the corner cases on the real chip. Then I can test the FPGA after and see how they differ. Hi again, guys. So it's been a new day again, and I've been working. So I put this up here, but I haven't stopped. I've been actually doing some programming on the C64 for this EEPROM. So I've been having this computer on the side here for a while, because I have a new strategy. I have been coding some dead test cart thing. So I was realizing that, okay, this is going to take forever if I test just one thing. But it was good to start that way, because then I can see I get data in and out from the CPU to the FPGA. So that's good, but now I know that is working. So I was thinking, okay, let's test all the cases. What I can do, I can wrap the FPGA code or VHDL code into a test code, so that it can test. You can see what's out on the pins on this one is the same as the output of my code, so it sort of matches, but that will take forever. So the second approach that I actually started on, well, okay, I'll get back to that. I will use a dead test cart kind of program, make my own, test old corner cases, and then when the CIA chip is working, and see that all those test cases are working, like test 1 to 40, then I can pull out the chip and then use the FPGA and see that my program is failing, or where it's failing, and can go in and fix that and go back. So yeah, that's my new approach. So I started on the CIA test cart, and I decided to work on in ultimate mode. Now I started looking up ultimate mode, and there's a lot of people deferring to use it. It's like, why do you want only 4 KU memory? Why don't you want all your rooms? But that's exactly what I want. I don't want the kernel to run. I want my own program to run. And since I'm also very new to this, I started looking at the test card, as you can see on World of Jani's website, and it has a disassembly. So I used that, and I based a lot of my code on that. I also asked help from Wouter, because I know he has been making many videos on the subject. So I asked him which assembly he used, but I ended up using Kick Assembler, and the reason is that it's so well documented. So I will continue like this, and now I will just test it on the real hardware, and then I will make more tests. Alright, so I'm just connecting everything up again. So this time I will have to program it again with my MiniPro. So we'll just basically then just borrow this USB from this JTAG thingy, and let's program it. Anyway, so there it's done. Let's move it over this, and then let's take the CIA IC, insert that, then I will remove the FPGA for now. This. Okay. Now we'll turn it on, see what happens. And then we will check on the screen. Okay, I looked in my folder after I made this automatic compile build script. I might have forgotten to delete the old file testcart.crt, so I might have programmed that. But oi. Bottles everywhere. It's quarantine time. Anyway, let's try it again. And we have a black screen this time. What? Maybe it's because I did a jump where I'm not supposed to do a jump. How difficult is this actually? I have to burn the bin files, because it could be that this bin file is incorrect. Let's have a quick look over it, see if it looks okay. So to look if it looks okay, we'll just see that our program is starting at 00 here, and it looks like it's doing that. And when we go to 1FFFF, we should have the pointers, and we have the pointers. So this looks correct. And they also point inside E area. So we'll try it again. And I'm getting a green screen again, so something is wrong. Now I even get everything on top row and not on that black thing there. So I was thinking to myself, the VIC2 doesn't have a reset input. So the state of the VIC is actually unknown at the start. So this emulator, maybe it's known somehow and not on the real machine. And then I looked in the test card, and sure enough, it is actually setting up the code for it. And I have copied it over to my code. And basically what I do, I copy all the VIC values into there. And there are 2F amount of values, and it's just a block of values basically. But what you also can see is that when you get down to here, I think it's not writing. I'm not sure if 1B is correct anyway. So what I've done, which seems to be working in the emulator anyway, is to follow the dust layer. I don't know if you are familiar with that log, which is really great. Actually, I don't know who it is. If you're watching my videos, please say hello. So what I do the same as here, and I think this is the same as doing in the kernel. So basically just load this initial value, so, and therefore we turn the VIC on and off for one, and the other thing is we get the extra row. Well, it couldn't hurt to test it now, so right, now it's programmed. Let's get it in there. So let's turn it on. Oh my god. Oh my god. It's working. So what I have now is the original chip. So it's actually reading something there. So now I'll try the FPGA and see if I get the same thing. Switch it off, switch over, connect the thing. This, make sure it's pressed down. We should have some power loss on this one, I think. Not sure if it's necessary, but then we know. Oh, well, we can disconnect this one. That's better, because we don't want to connect stuff that isn't powered up. We need the JTAG. Let's connect the JTAG. We'll remove the original chip. My chip pullers, I will just pull it out like this carefully. So. Yes. There you go. Now power to the FPGA. Turn it on. We have a red light in here. Let's start the program. Let's do a boundary scan. Initialize chain. Then we are going to assign CIA bit file. No bypass. OK. Program. There you go. It's programmed. So let's try it now. And now we should see something down here, I think. FFFF. Look. There's something wrong there, so there's something to fix. I find that very interesting. So the timer A is correct, but timer B is not. But when I come to think of it, I think maybe I have disabled timer B in my program. So let's have a look at the code. And this is the code. And let's see. Yeah, timer B is disabled. So that makes sense, but that's really cool. So my first test for timer A is actually passing. I'm really happy about that. Of course I have to test more things in timer A, but there you go. So this is how I will continue. Really happy about that. Just for the heck of it, what happens if I reset the FPGA? All the programming in the FPGA should be gone. Where the hell is reset anyway? It's up in here. Boink. Oh, look. And then now I will program the FPGA. Then programming. Oh, look, 0, 0. That's also interesting. Well, now the FPGA has been programmed, but we haven't reset the Commodore, so it hasn't received the initialization. So let's hit reset here on the cartridge. See what happens. We're back. So I've been working on this tonight. Gotten very far, I think. So now I have repeated the test 1